Okay, cool. Yeah, this is a tough act to follow. Hi, Ben, if you're still listening. Ben was my editor at the LA Times in his last job. And unfortunately, I'm still not a great programmer. So I hope that sort of the theme of this talk can be how you can kind of get started automating a chart without being the best programmer or the fastest. So let's see what goes on. Let's see what happens here. Um, so yeah, how we built our drought tracker kind of on the back of the Datawrapper API. What I main things I want to talk about kind of are how I learned to work smarter and not harder, meaning less JavaScript, more Python. Um, how this process really benefited us in terms of what we were left with, a chart for kind of all these different news events that we experienced weather-wise in the last year or so in California, and then we'll take a kind of a dive into how I did it, and maybe if there's time, you'll see some of my weird and bad pandas code. So look forward to that. Stick around. Let's get started. So smarter, not harder. This is something that one of my colleagues, Iris Lee, said to me one time, and I'm trying to take it to heart. So our first version of the drought tracker, it really it had a lot of Svelte JS graphics. It was kind of designed at a different time. It was I'll talk about that later maybe. But we had some bar charts showing reservoir trackers. Maybe if you live in the US, you've seen the US drought monitor has these splotchy maps that show kind of where the severe droughts are in the US and in different states. And so in some ways, JavaScript and D3 and Svelte can take you places that Datawrapper can't go. I tried in vain to make a map like this work in Datawrapper, and either I wasn't trying hard enough, or can't be done, or I'm just not smart enough. So some things there's a place for D3 and JavaScript, but in other times I was working too hard, I think. So in our first iteration of the drought tracker, we wanted to track like reservoir levels serving California. So showing these bars of like current water levels, or percentages of various reservoirs, and what the sort of like normal level would be for that time of year. So whenever I made this screenshot, Lake Mead was 27% full and 59% average. And this type of chart, I think, was really a product of the time where California was in a crisis. It hadn't rained in like what felt like forever, and we really couldn't imagine that it would ever rain again, because we had these like apocalyptic photos and headlines of like a 1,200-year mega drought. So yeah, we didn't expect it to ever rain again, but then it started to rain, and it started to rain a lot. Um, and it just kept raining for months and months. And pretty soon those bar charts I showed you, they just didn't make any sense anymore, because no one really needed to know that the reservoirs were very full, but what was more important was how things were changing. Or basically, we needed to pivot the drought tracker to something that showed kind of a longer tail. And all these other stories kept coming up, like a massive snowpack. Uh, we needed to rebuild this with like a lot more features, and something that can track these things over time rather than just give this snapshot. So in looking at it, I could have, or I think remember thinking about drawing some line charts and multiple charts of like those reservoirs, showing that over time. And then I realized I'm really not good enough at D3 and Svelte to figure this out. And we kind of need it now, or maybe even like weeks ago. Um, so I looked at Datawrapper, or maybe someone said, try doing it in Datawrapper. So we threw our hands up, we let Datawrapper take the wheel. And I think our first version was, made a single reservoir chart for like the state kind of total, and then use the API to duplicate that chart and kind of just swap the data, swap the title, and pretty soon I had like 14 versions of uh, a reservoir chart, but for Lake Mead, for Lake Powell, for Lake Berryessa, up in Northern California, Lake Shasta, I think is our biggest one. Um, Upsides of this was it was way less code. It was this, basically a single Python notebook running and updating all of these charts. Um, and importantly for me, changing the chart type if we needed to was relatively, painless. If you make a bar chart in D3 or Svelte and then you decide, actually, I need this to be a line chart over time, that's tragic, right? Guess you have to start all over. So data wrapper is just, change your data and click the button. And I'll talk more about this later, but the charts are also portable. So if you're writing a lot of stories about a record snowpack or the state of your area's reservoir levels, then you have this on your tracker, but then you also have like this chart kind of ready to go everywhere else. So here's that reservoir chart. This is the one that I kind of think started it all. California state government publishes, a sort of aggregation of all its like main reservoirs. So we started with this and then quickly was able to like duplicate it and make many, many more, and kind of just arrange them all on our page. And yeah, so news was going really fast, and we also needed to add like the snowpack chart, which has become really important and really useful for us. Also, you can see what kind of a wild year we had a while back with 250% of like 300% of average snow up in our mountains. It was tremendous. Um, so, the data wrapper API really let us like respond to news and keep our tracker kind of up to date with all of these things that, for better, well, not for better, kind of naively, we didn't consider, like ever seeing snow again. Uh, it was really that bad that we 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 thought snow was kind of extinct in California. Um, so a chart for every occasion. This just means once you've made an automated chart, it's there, it's ready. So, for example, these are the U.S. Drought Monitor graphics showing the kind of percentage of the area in various levels of drought in California over the years. And these two charts were made by hand by one of our graphics reporters. And every time we needed to do this chart, someone would have to, you know, do it by hand. And I think these were made actually before we, as the LA Times, used Data Wrapper. But now, like this is our new version, built in Data Wrapper. It's always ready to go. Whenever we write a story about drought, we can just add this chart in, and like boom, we have that extra value on our story. Uh, and here's some other examples of charts that we just have ready to go. So one day, an editor came into our channel and asked, like, "Hey, how about we do a precipitation gauge?" So I kind of used our drought tracker pipeline to pull this data in, process it, and kind of I just added it basically to our rig, and now we have it. Same with the snowpack chart, and all of my favorite little reservoir charts. And they're, so easy and so ready to go that they even land in print sometimes, like they did, uh, like last week. So, anytime we write about the Colorado River, the graphics request is already fulfilled before it comes in, and that makes me very happy. We can dive in a little bit. So let's kind of like unpack how we did the snowpack chart. First things first, someone asked me, what's the difference between using the data wrapper API and having like an auto updating chart? So you probably are all familiar enough with data wrapper, like you can connect a Google sheet or connect some kind of spreadsheet with live data. and you can get your chart to kind of update on its own, but it only gets you so far. There are all these other little things like on a chart that are important to add, such as, like maybe the last date of the data, or maybe your description has some dynamic variables, or even an annotation that you want to like kind of track across the chart or update a number there. Normally, you could easily do that by hand on the website. Anything you can do by hand on the Datawrapper website, you can also do in the API. All you need is, well, this isn't a beginner's talk, even though I would call myself a beginning coder. Um, Basically, our process, it starts, we have some Python notebook that download the government data, we clean it, we shape it into a format that Datawrapper or uh, some of our Svelte charts need. A GitHub action helps us, automate that. So we time it to run around the time that we know the departments, the agencies post new data. And then we have another set of notebooks in a private repo that handle the data wrapper stuff. So it updates the chart. It runs new dynamic variables, and it republishes the graphics, like, so that we have new stuff across the website. And here's kind of an example of some of the code. So I actually marked it up. We just set some variables, like little calculations, like the percent of average, the April 1st, which is like the noted sort of maximum or traditional maximum of the snowpack. It's percentage of normal. We also set some dates, and then we kind of build it all on these JSON objects, and we push it into um, like a little Python request, and we publish it, and pretty much everything's all done. Um, so I can't really explain everything about the Datawrapper API. Their docs are better than anything I could ever explain, and they taught me everything I know. So that's kind of it. It showed you kind of how I kind of was able to really throw my hands up and say, I don't need JavaScript to kind of skip the whole development process and go straight from kind of a data wrapper prototype to scaling up really fast, and really evolving our drought tracker in a matter of days instead of weeks. Um, and that had, a surprise kind of benefit of never having to make the same chart twice, which is really great because um, I like to tell people that data journalists are lazy. Um, and so if you've got these charts, if you know you're going to have to make it more than twice, then you might as well try and automate it. It's not too hard, and give it a try. It's actually kind of fun, I would say. And again, any customization you can think of doing by hand, you can also do in the API. Um, it's just a little bit of JSON parsing, which I would argue is also a little bit fun to play with. So with that, I will actually give a shout out to my colleague Paul Duginski, who recently retired and lends a lot of illustrations to this drought tracker. Here is his version of California in a sort of uh, green and happily watered state. So I'll answer questions in the chat if you have them. If not, thank you.
Thank you so much, Sean. It was great to hear a process that is probably going to become, unfortunately, more and more salient as people have to change charts based on climate data, which is changing more and more these days. Really excellent processes that you went over, and great to hear all of these considerations and everything. I do have one question for you that I have right at the top of my head. You mentioned dynamic annotations, and those are really interesting to me. Haven't seen them much in use. I wanted to ask if you could talk a little bit more about those. How do you choose the point to talk about? Is what does the editing process for those look like, and so on.
Yeah. So the dynamic annotations, really, I think we're just using them in the snow part, it's the snowpack chart. And um, I'd say honestly, like just specific to that one, it was kind of a compromise. So you could visualize a snowpack in two ways as like a percentage of its April 1st peak. So we're kind of building toward like this sort of um like almost hypothetical moment in time. April 1st is the time of year that officials typically say the snowpack is at its peak. So it's kind of a goal. Like we want to be at 100%. So we're following this kind of slope up. You could also visualize it as a percentage of like it the average for this date, which would kind of produce a kind of up and down, noisy, hard to read, and not very informative graphic. It probably because a line chart isn't appropriate for that. Um, but both numbers are important. So we wanted to put them in somehow. This produces a nicer chart and one that's more familiar. So we wanted to have that description reflect both numbers because both are newsworthy in different ways. Um, for this annotation, it's just helpful to kind of get the number directly labeled, but can't be done in an automated way without updating it like through the API. Because normally, but I don't think it's possible. I think this annotation has to be hand placed. Datawrapper doesn't automatically place a number at the end of the line. And it was an interesting hack because it's a multi-line chart, but made to kind of look like this shaded area is could have showed you the data wrapper part, but
Oh, I think I understand. It's the area fill underneath the
yeah,
line.
exactly. Thank you. I don't remember the word. Actually, Shayla, that I frequently break things in data wrapper, ask the team why it's broken, and then they quickly, easily point out that I've done something silly. So I really appreciate the data wrapper team for
Well,
like
interesting questions though. So it's never you get those points. It's always something that, oh, I didn't know we could do something like that, and that's why you ran into
leave
something.
it to me to break things in particular and unexpected ways. I hope I'm answering,
Well,
though.
mm, no, it's fantastic. You did a great job. It was wonderful hearing you speak. Thank you again for your presentation. Great to put a face to the name over Slack.